As soon as I started working on my character controller, I was having ideas for maps I haven't seen in other games. I want to be able to have maps where the gravity changes, the players are on poles of a planet, players can go in and out of space, all with networked moving platforms, ladders, and man cannons. So that's what we're doing today. First, let me introduce myself. Hi, I'm Frank. I wear sunglasses indoors. I'm kidding. I make games. I've been working for a while on a multiplayer first-person sword combat game currently called Castle Wars. A couple of technology things. I'm using Fishnet for networking, which will actually matter today. And I'm using Easy Character Movement 2 for a base character controller. I got it in a Humble Bundle a while ago and I'm super familiar with it, so that's what we're using. I actually just released a video getting advanced first-person movement mechanics like dashing, sliding, flying, and swimming into the game, so go check that out. Okay, so first up today is moving platforms, and if you watched the last video, a lot of these things are going to have Easy Character Movement 2 examples. So this one does have an example, but it's not networked. It's all done client-side, which theoretically shouldn't be a problem as long as we were to keep track of the time that the platform started. I want to network it just because I think it'd be easier to keep in sync. Also, these platforms only support moving between 2 positions, and I want to expand it to support as many positions as we could want and allow for different intervals of time between them. We'll need to create an object and add a Fishnet network transform component to it. This will be the movement platform, and the network transform component will control the synchronization of the position of the platform. I also created a script that linearly interpolates the position between a current indexed and a next indexed position in an array. This way we can add as many positions as we want, and I set the script to only run on the server so we can worry solely about synchronization on the clients. We don't have to do any sort of positional updating. We can also move these positions in real time, which makes me want to come up with some sort of like moving platform positions where the platforms sort of move between moving platforms. I think would be kind of cool. Okay, so next I want to add in anti-gravity zones or rooms or something. This feature does actually have an example in the Easy Character Movement 2 package. I'm gonna actually pull up OBS. Oh, we also got to pull up Unity. This is actually a really good time to tell you I have 2 mobile games on the App Store and on Google Play. One is called Launch My Dog. It's about shooting hot dogs into a bun. And the other one is called Poke My Balls, which I'm not even going to explain. Go check them out. They're fun. So this is what the example looks like. You see we can move side to side. We can't move any other direction. If we jump and we press E, we actually swap the gravity direction. So now we are upside down and we can do that. We actually have to hit a button to toggle it, which is normal, but we also have to be in the air, which is not normal, and I'm going to tell you why in a second. I added a room to invert the gravity within, and I set the materials to indicate where the gravity is actually going to change. Okay, so now we're in first person, and if we go to this gravity room, you can see that when we walk into the red zone, oh, hey, look, we're walking on the ceiling. And when we walk out of the red zone, we're back on the floor. I've set it up so there's a trigger zone, and inside the trigger, the gravity will be set to a specific vector. The previous gravity will always be saved on each player. Okay, so why was it weird that we need the player to be in the air to change gravities? And actually, you might be able to tell, if you have an astute eye, that we have a little debug message that says forcing a jump. So the way that the character controller works is that it will stick to a surface. Even if we change the gravity, the character controller is set to stick to whatever surface it was already on, which means that if we change the gravity and we don't jump, we don't fall. So when we enter the trigger zone, we actually force a jump so that we get rid of the surface that we're stuck to, or we at least remove the reference to it. And then the gravity changes, we flip directions and fall. I actually took this idea and I made it a little more dynamic, and I added a map called Gravity Labs, in which the gravity of the room changes on a set interval. 3, 2, 1. So the gravity changes. A whole video on me making this map is going to come out in the near future, so get subscribed. You're really not going to want to miss that. I think that this is a cool little mechanic that keeps the gameplay a little fresh and prevents people from camping, and it will just keep people on their toes. Okay, planets. So, of course, there was an example in the Easy Character Movement 2 package that I started with. We start spawned on this planet. This is something that we're going to want the ability to do, but we don't want to necessarily assume will always be the case. The example uses the player's position and the center of the planet to calculate a gravity vector, and actually let's go and look at this. So you can see that the gravity vector is actually updating in real time. That's just a directional vector pointing towards the center of the planet. You may have noticed even in the last video that we do actually have a planet here, or planets, plural here. So this is what I have. we have a trigger zone, which you can kind of see because I put a material on it. And as soon as we go inside of that, we are constantly setting the player's gravity to... We're going to get to that later. I stole all of the rotation and gravity vector building code from the example. I made this all trigger activated so we can jump in and we can jump out. This way I could potentially build a map where the players jump between planets. This is on a smaller scale, but I do have an idea for a larger version of this. Also, I had to fix name tags since they would rotate, assuming that the ground plane was always the same. So here's them working. Also, I built a map in which the players spawn on the poles of a planet. So you actually just play around on a planet. A full video about the making of this map is also going to come out soon, so get subscribed. Okay, so next is teleporters, and what would you guess? There's an example for it. I haven't been intentionally doing promotion for this Easy Character Movement 2 package, but it's really good. I've been using it for a while, and if they wanted to sponsor me, I wouldn't say no. Okay, so here's that example scene, and you can see that we have 2 little red boxes, and if we... Oh, the example just doesn't work. Okay, well, regardless, I based this off of the example in a previous version of Easy Character Movement 2, so I can actually show you what I have. So here's the teleporter. And as you can see, we can teleport and go through it. I stole the code from the example, but of course it's not networked. Easy Character Movement 2 has some networking examples, but doesn't assume that every single feature is going to be networked. Other than ticking the enable teleport box on the fishnet network object component, we did actually need to update our scripting a little bit. So when we go through a teleporter, we have to clear what is called the replicate cache, and that is a series of cached character state information packets. They get cached on the server to validate further states, and I'll go into this a little more in a later video. Fully on client-side prediction. I haven't fully implemented client-side prediction yet, but I've done it a little bit, and it's really, really cool. It keeps players from cheating. I don't feel like having to build in an anti-cheat because this is all going to be custom games, so I think this is going to be enough anti-cheat for me. Get subscribed. It's going to be a good video whenever I get around to making it. Back to teleporters. I did have to make it so that the players would rotate correctly. So these teleporters are facing the same direction. If I walk into this one, we have to spin ourselves around 180 degrees when we come out. And I also made it so that the player gets launched at the same velocity that they enter one portal out of the other one. This way we can actually dash into the portal. One last note on teleporters, the actual portal part is green because I'm eventually going to add some visual effect of what the portal can see on the other side. This is just a minimum viable product, so I don't need to do that yet. Okay, ladders. So ladders were something I had in the last prototype, and they function exactly the same in this one. Players interact with the ladder via the interaction system. The player will then interpolate to the closest point on the ladder path. Then when the player moves up or down using their directional movement, the player will actually move along that ladder path, and then when the player exits the ladder, they will linearly interpolate as close to a set position as they can. The player will automatically get off the ladder if they hit an end of the ladder path, and they can also interact or jump to get off at any point. Okay, finally, we're doing man cannons. This is something that I really wanted in the last prototype and had no idea how to even conceive of starting. They are the first, only, and last feature today that does not have an example in the Easy Character Movement 2 package, and it's going to kind of test my knowledge about how movement abilities work. I dubbed the man cannon movement directed movement due to the lack of ability to control the position of the player. The general idea for directed movement was that the player steps into some trigger, they move along a predetermined path, and then when they hit the end of the path, they fall off. My original pathing solution, it didn't work. It was kind of broken. It was just a set of points that the player would move linearly between. I had issues figuring out where the next point on the line was for the player, and there's got to be some way of smoothing the path. Some of you may know where this is going. I learned about splines. Splines are a set of points that have a smoothed line between them. If you've ever used Photoshop, think of the Bezier tool. That's sort of how you edit splines. You have positions, and then you have something that modifies the angle at which the line connects to that position. I'm not 100% sure, but spline has to stand for something like smoothed piecewise line or smoothed point line or something like that. I'm probably way wrong, but those are my best guesses. The best part of the Unity spline package, which is what I'm going to be using, is that if you have a reference to the spline, you can call its evaluate function. This evaluate function, when given a value between 0 and 1, it'll give you a point on that spline for that ratio. So 0 is the start of the spline and 1 is the end. So the updated directed movement flowchart is that the player will enter a trigger zone, get the reference to the spline as well as a traversal length. Then for a set amount of time on the spline, the player will call eval to get a new point on the line and then move to that new point. And then when the player would call eval with a ratio of 1, meaning that the traversal time has elapsed, the player will fall and the directed movement will end. And this works so much better. And it would probably pass in 90% of cases, but I want one more layer of polish. So I added an animation curve to the man cannon component. This animation curve maps values from 0 to 1 to values from 0 to 1. This way we can control the progression of our traversal. If we want to go faster at the beginning, we can. And if we want to slow down at, say, the apex of our verticality, we can do that as well. I added some dots along our spline in the scene view to indicate the speed at which the player will be traversing certain parts of the spline. And with all that done, we can now go to the training ground where we have a vertical man cannon to the top of the fly zone, an angled man cannon from the top of the fly zone to the top of the anti-gravity zone, a vertical man cannon which goes up next to the fly zone but doesn't force us atop it, a ground to planet man cannon, a planet to ground man cannon, and a planet to planet man cannon. Planet to planet works right out of the box since gravity rotation is controlled completely independently, and I think that these are some really, really cool features. They add to our movement sandbox in such unique and I'd honestly say necessary ways. The game sort of is gonna need something to set it apart because you can play any sort of custom game. Having such a wide sandbox and the ability to sort of create as many experiences as I can possibly think of is hopefully going to help maybe push this game to where it needs to be. It might add a certain level of gimmickry, but if it makes it more fun, it makes it more fun. Well, that's all I have for today. I'm going to spend the next while making a couple of maps as well as making an interaction and a health system. So get subscribed. If you like this video, like it. If not, really, why are you still here? Comment if you have any questions, music recommendations, comments about how many times I fixed my hair during the video. You know the drill. I actually got a comment last week about a Discord, so I made one. It doesn't have much there. But I'm there, and if you have any questions or if you want to see smaller step-by-step updates on the game, the link is in the description. Oh, and download my 2 games, Poke My Balls and Launch My Dog. They're on iOS and Google Play. Go try them. I really think you'd like them. All right.